Hi, I'm Kellen Yu from New York City, and I'm an incoming freshman at Cornell University. This is my submission for the SSCS 2025 Arduino contest. According to the World Health Organization, over 1.3 billion people live with disabilities, and more than 70% face unemployment. Many can't perform manual labor, so cognitive work is often their only viable path. But today, most jobs, especially remote ones, require access to a computer. That makes the ability to operate a digital device not just helpful, but a gateway to employment, education, and independence for those living with disabilities. That's why I focused on assistive technology and specifically set out to build a replacement for the computer mouse, something that can be used by people with limited upper limb function. Before I started designing anything, I set clear goals. 1. My device had to be affordable. 2. It had to be configurable to different user needs. 3. It had to be minimal in hardware. And 4. It had to align with Arduino's mission of accessibility and community-driven innovation. This is why from the very start, I decided that my project would be open source and I would use technologies and parts that were accessible to the general public. The result is a head movement-based mouse. It turns head motions measured by a gyroscope to cursor movements, which then it sends over Bluetooth. The device can mount easily to headwear, like headphones, and can be paired with clicking inputs, like tongue switches or foot pedals. Here's a quick demo of me using it to carry out basic tasks on a computer. I chose to base my project around the ESP32C3 microcontroller, both for its support of Bluetooth and Arduino and its relatively low cost. I also chose the low-cost BMI 270 IMU to track head movements. My device is battery powered with an estimated battery life of 6.5 hours. It features an easy-to-use clamp-style mount and is very compact in size, being only 5.5 by 3 by 2.5 centimeters. It features custom input ports for various switch types. Its simple two-piece enclosure can be easily 3D printed. Commercial alternatives exist, but they're prohibitively expensive. My device offers the same capability as these other devices while only being a fraction of the price and open source. Going to a quick overview of my workflow, I designed the schematics and PCBs in KiCad, got it taped out by JLC PCB, designed the enclosure in Onshape, and programmed everything in Arduino IDE. One of the early challenges I faced was mouse jitter due to noise in the IMU measurements. To solve this, I thought about noise as a high-frequency signal and fed data into a low-pass filter with an empirically determined cutoff frequency. This worked very well and removed virtually all jitter. Another challenge was sensor misalignment. Since the IMU operates in its own tilted frame, movement wouldn't line up with the screen. I fixed this by using the standstill gravity vector from the accelerometer as a global reference. I calculated the angle between the IMU's measured gravity vector and the ideal down vector, found the rotation axes orthogonal to both, then used Rodriguez's formula to find a matrix that would represent this rotation. Now, even if the device is mounted at an angle, the cursor still moves as expected. All code and CAD files are on GitHub. I'm proud to have created a low-cost, adaptable, and open source tool that helps those with movement disabilities access digital workspaces and the opportunities that they unlock. Thanks for watching.